now we could, let's make it interesting, make it 0.3 so that this happens much more faster. Okay, let's try to go back here, choose an OR gate, update your truth table, choose number of nodes to be only 1 for now, change your learning rate to 0.3, initialize your network, train your model. Now you see the pace at which it is running. It is running
Mm.
much more faster because the
Mm.
learning rate is very high. And how is that happening? That is happening because these weights are also changing so fast. Okay,
Mm.
that is directly connected to this. You see, last time we were waiting more than 2-3 minutes. Okay, or maybe
Okay.
five
So
minutes.
now predicted output 0.4 means it is below zero point 0.5, it is taken as 0. And
Yeah,
if it is above 0.5, it is taken as 1. Am I
yes, absolutely.
am I saying that as the right thing?
Yes, yes, exactly. You're on dot. So like it
Mm-hmm.
basically realized a relationship.
So
Yes.
it is a dumb fool. For a human
Mm,
being, it is very easy. I know 0 and 0,
yes.
or means 0, and 0 1
Mm,
means 1, and 1 0 is 1, 1 and 1
yes.
is 1. We know is as
Yes.
simple as that. For
Yes.
computer, it is doing all this tamasha to find out the answer.
Now you're on dot. So that is one reason for which you should never think ChatGPT learns about you. Okay.
Mm.
ChatGPT also does the same thing, but in a very big way. When I say ChatGPT does this in a big way, here how many parameters are we looking at? Look at this and tell me.
Mm-hmm.
5 parameters.
5 parameters, yes.
Okay.
Three weights
But
and two
anyone,
bears.
only five, three weights and two biases. All right. But when
Okay.
you speak about any large language model, right? So how many weights do you have? So let's try to, how many parameters? Not let's try to use weights. So
Okay. No.
some small model also you try to take something like a Quen 3.5. How many parameters you have?
2 billion.
2 billion,
The,
0.8
oh,
billion,
Quen is Chinese
27
model, na?
billion, 35 billion.
Quen is Chinese
Quen
model,
is one
right?
of the Chinese model. Yes,
So what it does
yes,
is,
you are
you
true.
mean, one second. What this model
Hmm.
does is, it takes 2 billion uh,
So
weights,
like
is it?
let's try to make the statement in this way.
Mm-hmm.
It is a neural network with so many different kinds of connections. Okay, where in
Mm-hmm.
which you have all of the connections. Along the connections, you have these weights and biases. Correct. So now
Mm.
effectively you have 3 billion number of weights in that network.
Oh, 3 billion weights. I mean, that much of probabilities are already fed
3
into it.
billion weights and now you are getting it. Okay. So like we'll go back and look at this one more time.
Mm. So,
Where is that?
okay, so it is.
Let's go back into neural networks. Okay. You were asking about like what if I have 2 layers or 3 layers?
Mm.
Okay. Along each of this layer, you have same kind of weight business.
So you take two layers and
Plates and
simple,
simple,
two layers
two
and
lanes and
nodes also make it two or
yes.
something.
It's up to your why two. Let's keep it 10.
No, just for understanding, from one we went
Yeah,
to two,
10. You
na.
want
So
only two? Okay, fine. Let's keep it to two. Okay.
okay, there
You want
also,
both the layers to be 2 by 2?
yeah, 2 by 2. Okay, 2 by 2, what
Okay,
happens?
not two.
Okay, two by
Two
two,
by two
what
happens
happens?
same way. So let's try to look at it in more detail.
Mm-hmm.
So now what is happening? Let's try to understand this. I0 and I1 is entering into this. So you have two
Inter.
multiplications, one bias addition. And I0 and I1 is entering into this. So there are two multiplications and one bias. So now you have your intermediate one, intermediate two. So now
Mm.
intermediate one and intermediate two will be dealt as input to this node. Okay, again intermediate one and intermediate two will enter into this. So two multiplications and then there is a bias. Intermediate one and intermediate two will enter into this. There are two multiplications and one more bias. So that
Mm.
will happen. And now you have intermediates second layers first, like intermediate to 2 1, intermediate to 2 2. Let's call it like that. So now intermediate to 2, 1 is basically entering into this. Intermediate to 2, 2 is entering into this. Along the path, you have weights getting multiplied and bias getting added. A soft match is applied here. Okay, so many multiplication and additions are happening. Okay, and if you try to initialize your network and go back and look at this, so if you have two nodes as part of your hidden layer, or like four nodes totally as your layers, you basically have 15 number of parameters.
Okay.
Okay,
How many weights and how many bias there?
you can count them here. Already here there are 10 weights and 5 biases.
Okay. So
Okay,
you just go to the neural network. Okay.
so now like see, every
One,
node
two,
is
three.
associated with one bias, right? Let's break
Okay.
it
So
like this. So one bias,
two
two
bias,
bias, three bias, four
four.
bias, and then along with your output also there is one bias. That is basically five bias.
Okay, five bias. And
Okay.
weight
And
is?
number of paths. Number of paths is like one path, two path, three, four. This basically in this layer you have four weights. And in this layer you have your like one, two, and then this is also coming in this way. This is also going in this way. So you can count number of weights. All right. So 4 plus
Oh,
4 may be 8. 8
eight.
plus 2 is the 10. So 10 plus totally 5 is 50.
Oh, paths. We can consider as a path.
And
Okay.
number
Okay.
of paths is equal to number of weights.
Okay.